Good morning, everybody. My name is Praveen Samuel. I'm the lead in diabetes technology at BC Diabetes. In the next 8 minutes, I will share our experience in implementing open source APS in 171 patients, training and supporting them, and finally presenting our results. I will quickly cover the following topics. What is Loop? How does it work? What do you need? The BC Diabetes process, results, and the discussion segment will be led by Dr. Elliott. What is Loop? Loop is shorthand for automated insulin delivery using open source APS. APS is short for Artificial Pancreas System. In Canada, these systems compete with retail systems from Tandem and Medtronic. People who use Loop systems are called loopers, and when they use it, they are said to be looping. Confusingly, one of the open source APS apps running on iPhones is also called Loop. Its interface is shown on the slide on the right. Currently, Loop is unregulated, unapproved, and experimental, and yet worldwide, more than 30,000 individuals are considered to be looping. The 171 cases that I will present to you today were all provided one of 3 BC Diabetes Loop apps at no charge after they had signed a 2-page waiver of liability and informed consent. At BC Diabetes, in addition to the Loop app, we also offer 2 other systems, and their interfaces are shown on this slide. FreeAPSX for iOS, or FAX in short, and Android APS for Android users. These systems have more advanced features and a more powerful algorithm compared to Loop. Let's look at how Loop works. Fundamentally, an APS user requires 3 components: a CGM, a smartphone on which the APS app is installed, and a compatible insulin pump, most commonly the Omnipod Eros and Dash. Once connected, the software runs an algorithm every 3 to 5 minutes, and depending on the fluctuations in the user's sugar, it increases or decreases basal rates, suspends or resumes insulin delivery, and gives microboluses of insulin. The BC Diabetes process. We have found client selection to be important. The ideal client should manifest lower levels of anxiety, be tech savvy, have good insulin adjustment skills, and of course, must sign an informed consent and waiver. All new loopers typically had 3 appointments with me: an informational session for 30 minutes, Night Scout tutorial for 30 minutes, and an installation, configuration, and orientation session, which lasted 90 minutes. Then they were followed up for 3 to 5 consecutive working days or more where necessary, during which their CGM and looping data were discussed and interpreted, and adjustments were made to their configuration targeting optimum glycemic control. Subsequent follow-ups were at 3 weeks, 3 months, and every 6 months thereafter, or as needed. We use a remote CGM monitoring anonymized URL called Night Scout to track our patients' numbers, compile reports, interpret their data, and make configuration adjustments. Every patient was provided a unique Night Scout account by BC Diabetes at no charge. What you're seeing on your screen is a sample Night Scout tracing. The blue peaks and valleys on the top are adjustments to basal rates made by Loop. The multicolored dotted lines in the middle and bottom are time-specific CGM data. The number on the top right is a user's current interstitial glucose accompanied by the trend arrow. The blue bubbles are microboluses. Night Scout reports look very much like Clarity or Libre reports. The difference is that sugars can be traced indefinitely over days, weeks, months, and years. The BC Diabetes EMR has a direct Night Scout feed incorporated into the backend, making patient care seamless. Let's look at demographics now. This slide and the next 8 slides all show 4 rows of data, a row for each of the 3 open source APS apps, and at the bottom, a row labeled total with the combined data of all 3. Looking at the totals, of our 171 subjects, 44% were female, average age was 36, average duration of diabetes was 20 years, and 27% were of pediatric age. Looking at individual APS apps, 58 were on Loop, 101 were on free APSX, and 12 on Android APS. The sex and duration of diabetes was similar for all 3. Of the Loop users, average age was lower, driven by the 41% of pediatric clients. 37 clients changed apps, all 37 going from Loop to free APSX to take advantage of the latter's advanced automation features. Let's look at our results. On this slide is shown time in range. Looking at the total row, starting time in range was 64%, and time in range on Loop was 83% for an increase of 19%. Almost identical trends were shown for Loop and free APSX. Android APS users had a higher starting time in range. Here is shown time in range results for 37 users who migrated from Loop to free APSX. Free APSX, average improvement in time in range was 10%. 4 clients who made the Loop free APSX transition have recently returned to Loop. All had a time in range of more than 84% on Loop. We now move to time below range. For the group as a whole, time below range was 3.9% before Loop, 2.4% on Loop. All 3 groups were similar. We now come to A1C. Considering the 3 algorithms combined, A1C pre-Loop was 7.2. A1C and post-Loop 6.6, a change of 0.6. Similar improvement in A1C was found across the 3 individual algorithms. The next 3 slides show changes in diabetes-specific quality of life measures: diabetes distress, fear of hypoglycemia, and insomnia index. Each of these measures have detailed definitions, which I will not relate today, because for all 3 measures, the starting level of QOL was in the low to mild range, and then became lower still. Looking now at diabetes distress, the combined group pre-Loop value was 1.9, a level of up to 2 considered low to mild. This fell to 1.2 on Loop. Similar results were shown for all 3 individual apps. For fear of hypoglycemia, low values are those under 54. The average pre-Loop score was low at 37.6 and fell further to 29.8 on Loop. Similar results were shown for all 3 individual apps. The Insomnia Severity Index defines absence of insomnia at scores of 0 to 7, subthreshold insomnia from 8 to 14. The average pre-Loop insomnia score was in the subthreshold range at 8.6 and fell to 7.2 on Loop. There have been no reported episodes of diabetic ketoacidosis. When I first prepared these slides, no episode of severe hypoglycemia had been reported. However, 3 weeks ago, we had our first hypoglycemic seizure.
Thank you, Praveen. This is Dr. Tom Elliott. We come now to the discussion, the business end, I guess you would say. And I know that all of you would like to know the answers to the questions I've put on the slide. and I hope I can answer them satisfactorily. We're going to answer the question, is looping safe? We're going to try to answer, is it better? And then think about what's going to be on in the future. Is looping safe? Well, the major problem with type 1 diabetes in the modern era with CGM and compliant patients really is severe low sugar. What I've done to help answer the safety question is to compile incidents of severe hypoglycemia in published studies that I think are relevant to our discussion. I'm going to start with a large DIY safety study that was performed, published in Diabetes Care by Lum et al. Last year. And it looked at outcomes in individuals who had self-installed the Loop app. So they built the app themselves, they'd installed it, and then they reported to the investigators what happened over the 6 months. So the investigators themselves never met any of these patients. These are people from all over the United States giving their outcomes. In total, there were 246 patient years of data, and there were 51 episodes of severe hypoglycemia for an index rate of 18.7 per 100 patient years. This seemed like a high number to me, but interestingly, in the 6 months prior to the study, the incidence of hypoglycemia was 10 times that seen in the study itself. So 18.7 for people who install Loop themselves. Well, what happened in BC Diabetes, Praveen mentioned that we only a couple of weeks ago had our very first severe low. Our study involved 188 patient years of data, so that one episode translates into an index incidence of 0.6 episodes per 100 patient years. Towards the bottom of the slide, I've listed 3 studies of retail artificial pancreas systems. Only one of the 3 was of a size or a number of patient years that was similar to the BC Diabetes study. And this was Brown's study last year of Omnipod 5, which had 235 patient years of data, 3 episodes of severe low for an index rate of 0.8 per 100 patient years, similar to the BC Diabetes experience. Both Tandem and Control-IQ and Medtronic had small studies, Tandem with 31 patient years and Medtronic with 55 patient years, and no episodes of severe low were reported in those 2 studies. So I think we can say that the BC Diabetes experience is similar to the Omnipod experience, perhaps less selection pressure than Omnipod may have been in the Omnipod study. At BC Diabetes, we do have some screening, but we actually say yes to just about everybody. Is looping better? Well, to really answer that question, we're going to need a huge randomized controlled study where the allocation to the type of artificial pancreas was random. Of course, we didn't do that, though we hope to do that in the future. To help answer it, I've looked at real world data from our clinic here at BC Diabetes, and we did a database query pulling the data on every single person with type 1 diabetes who'd been seen since January the 1st, 2020, roughly the time we started our doing looping at BC Diabetes. We've seen 875 type 1s in that time, and this is on the top row, the total row. And the last A1C average for those 875 was 7.5. In the bottom part of the slide, I've listed decreasing A1C by method of insulin administration. You can see that by far the biggest group of patients at our clinic, more than half, are using MDI, 479 for an average A1C of 7.8. We have a lot of patients using the Omnipod pump who aren't looping. They're using their Omnipod with a Dexcom, but there's no there's no feedback loop there. For those 111, the A1C was 7.8. We have 59 people using Medtronic pumps who aren't using the Medtronic Guardian sensor and therefore are not using artificial pancreas. Their average A1C was 7.6. We have 22 Medtronic pumpers who are using the full auto mode, and you can see that their A1C is slightly lower at 7.4. We have 27 users of Tandem Control-IQ, and their A1C was 7.8. And then finally, the Omnipod open source APS data that Praveen showed, we've got 177 here. There's a few more since we made those previous slides, but 177 with an average A1C of 6.6. So is looping better? I think all we can say really is that BC diabetes people who are on Omnipod APS open sourced have lower A1Cs. Is looping scalable? This is the big question. And the three factors that limit it in September 2022 are listed on this slide. The first one is that of regulatory lack of regulatory approval. The Loop app was submitted to the FDA early last year, and everybody's waiting patiently for a verdict. No other open source APSs have been submitted to any regulatory agency worldwide. The next one is the availability of the app. So at BC Diabetes, we build the app. The two iPhone apps are beta testing on Apple's test flight environment, and we share those apps directly. The Android APS is available openly, and anybody who, and we're willing to share it with people who meet our criteria for informed consent and waiver. So the app is available through BC Diabetes and through the connections that already exist in British Columbia and across Canada. The final factor really is that of technical skill. Praveen's presentation was very modest. He didn't tell you that it was actually he who did every installation and did all of the follow-up in the first week. He's acquired a great deal of skill in the last 2.5 years, and those skills are very difficult to scale. At BC Diabetes, we have hired a diabetes technologist who will be Praveen's backup, and we think that this job description will become much more widely known as other clinics embrace the artificial pancreas technology, particularly open sourcing. Praveen would say, I think, that that Loop is relatively straightforward and relatively easy to learn and to teach. It's quite like Tandem's Control-IQ for those of you who've used it or used the simulator. Free APSX and Android APS, on the other hand, are more complex and do require special training. We're happy to offer that training to anybody who'd care to come by BC Diabetes. So in conclusion, we've presented our data of 171 clients who are looping on open source artificial pancreas systems. We had what we consider a relatively low incidence of severe hypoglycemia, leading us to conclude that it's safe in our hands, at least. We think that the evidence that it improves glycemic control through raising time in range and lowering the A1C, we think that's incontrovertible. And we have data to suggest that the quality of life for our people who were looping was pretty good when it started and better still when they finished. Finally, we're excited about where looping is now, and we look forward to collaborations with many more of you, those of you who've heard this talk and those of you who we hope will hear it later and look at our published data as well. We do welcome collaboration. Thank you very much.